Hey everyone, and welcome to this explainer. Let's just jump right into it. Now, for decades, we've known that our planet is getting warmer, but recently, a new and frankly striking reality has emerged from the data. The warming of our planet isn't just a steady, predictable climb anymore. It's actually speeding up. Today, we're going to unpack exactly what the science is telling us about this acceleration, why it's happening, and most importantly, what it means for our future. So this brings us to the core mystery of our explainer today. Is global warming actually speeding up? And if it is, why on earth is our planet accumulating heat at a rate we've quite literally never seen before compared to previous decades? We're going to look at the undeniable physical evidence and the hidden mechanisms driving this rapid change. Here's our roadmap for today. We'll cover the reality of acceleration, evidence from around the world, why the pace is increasing, the high stakes for humanity, and finally, the path to a solution.
All right, part one, the reality of acceleration and setting our baseline.
Before we can really grasp how fast things are changing, we need to get our definitions straight. Let's bust a super common myth right off the bat. People use global warming and climate change interchangeably all the time, right? But they're not actually the same thing. Global warming specifically means the long-term increase in Earth's average surface temperature. Climate change, on the other hand, is the broader ripple effect. Stuff like shifting rainfall, rising sea levels, and those crazy droughts we've been seeing. So, simply put, global warming is the specific engine driving the broader domino effect of climate change. To truly understand that warming, we've got to talk about the natural greenhouse effect. Imagine a freezing -18 degrees Celsius. That's roughly 0 degrees Fahrenheit. Without natural atmospheric gases like carbon dioxide and water vapor trapping the sun's heat, that would literally be Earth's average temperature. We'd be a giant frozen rock. Instead, this natural greenhouse effect keeps us at a very comfortable, highly livable 15 degrees Celsius. So, the problem isn't that the greenhouse effect exists at all. The problem is that human activities have completely overloaded it, making it way too efficient at trapping heat.
Moving on to part two, evidence from around the world and the physical proof. So how do scientists actually know the warming is accelerating? Well, they look at our highly interconnected planetary system. Right now, Earth has a positive energy imbalance. Basically, it's absorbing way more energy from the sun than it's spitting back out into space. But where does all that excess heat actually go? This is wild. Roughly 90% of it gets absorbed by our oceans. Only about 5% warms the land, 3% melts the ice, and a tiny little 2% actually warms the atmosphere. Let that sink in. The record-breaking atmospheric heat we literally feel on our skin every summer, that's just a tiny 2% fraction of the whole shebang.
Because the climate system is so massively interconnected, scientists don't just look at one thing. They rely on multiple totally independent datasets gathered from satellites, weather stations, and ocean buoys. And when we look at all these independent metrics together, the trend is crystal clear. Surface temperatures are shooting up, ocean heat content is hitting unprecedented records, glaciers are shrinking globally, and Arctic sea ice is thinning out. If only surface temperatures were rising, scientists might actually question the data. But when every single independent metric points to the exact same conclusion, the reality is totally undeniable. The pace of warming has definitively increased.
Part 3. Why the pace is increasing. Exploring the hidden drivers.
Okay, so we know it's happening, but the absolute critical question here is, why is it speeding up? Well, it essentially boils down to this core formula. Continuous human emissions plus climate feedback mechanisms equals accelerating global warming. We all know that burning fossil fuels, coal, oil, and gas, dumps massive amounts of carbon dioxide into our atmosphere. But what happens next is where the real acceleration kicks in. That initial warming from human emissions actually triggers nature's own interconnected systems to amplify the heat.
We can clearly see how this builds by looking at one of the most powerful natural amplifiers out there, the ice albedo feedback loop. Think of this like a snowball rolling down a really steep hill, just gathering speed. Step 1, the initial warming causes bright, highly reflective Arctic ice to melt. Step 2, that melting exposes the much darker ocean water underneath. Step 3, because dark water isn't reflective at all, it absorbs way more solar energy. And finally, step 4, all that extra absorbed heat causes even more warming, which melts even more ice, and the whole cycle just repeats itself. It's a self-reinforcing loop that drastically speeds up global warming. And then we have another massive hidden driver, permafrost thaw. Permafrost is basically permanently frozen ground found way up in high latitude regions. For literally thousands of years, it's acted like a giant planetary freezer, locking away enormous quantities of organic carbon. But as global temperatures rise, it's like someone left the freezer door wide open. The ground thaws out, microorganisms wake up and start decomposing all that ancient organic matter, and boom, potent greenhouse gases like carbon dioxide and methane are released right back into the atmosphere, causing, you guessed it, even more warming.
Which brings us to part 4, the high stakes for humanity, looking at the consequences.
With the pace picking up, we really have to face the reality of what this means for us. Look, this isn't just about saving the polar bears anymore. It's about the fundamental safety of our own human societies. The sheer massive scale of these physical consequences triggers a very real chain reaction. A warmer atmosphere actually holds more moisture, twisting our rainfall patterns to cause both devastating flash floods on one end and prolonged brutal droughts on the other. That dry vegetation then acts as the perfect kindling for extreme wildfires. Meanwhile, warmer oceans are supercharging tropical cyclones, making them stronger, wetter, and way more destructive. And all that melting ice and expanding warm water, that's driving an accelerating sea level rise that directly threatens vulnerable coastlines all over the globe. And these physical impacts don't just stay in nature. They ripple aggressively straight through our economies. As warmer, far more acidic oceans cause massive marine disruptions, like those heartbreaking mass coral bleaching events, our biodiversity absolutely plummets. Up on land, the 1-2 punch of extreme heat and severe drought heavily threatens our global agricultural productivity. This perfectly sets the stage for major water insecurity and widespread infrastructure damage that literally affects every single sector of the global economy.
This actually brings us to an absolutely critical scientific concept you need to know, the climate tipping point. This is basically a threshold beyond which a part of the Earth's climate system undergoes massive and potentially irreversible changes. We are talking about monumental events here, like the complete destabilization of the Greenland ice sheet or a massive, widespread dieback of the Amazon rainforest. Once we cross those lines, we can't easily go back. And the scary part, the faster the warming, the quicker we speed toward those tipping points.
Finally, part 5, the path to a solution and the cure. Okay, so we've diagnosed the illness, and now it's time to focus heavily on the cure. Because honestly, the single most important takeaway from all the science is that we are absolutely not helpless here. The future is not predetermined. I really want to emphasize that. The future is not predetermined. The ultimate magnitude of future warming depends entirely on the choices we make today, right now. Every single fraction of a degree truly matters. By actively reducing greenhouse gas emissions today, we immediately slow the rate of warming and drastically slash our future risks. We have real agency in this fight.
So what exactly is the cure? Well, the roadmap away from fossil fuels requires rapid, decisive action across basically every sector. Beyond making the huge transition to clean energy sources like solar, wind, and hydro, improving our global energy efficiency is absolutely paramount. I mean, the cleanest energy is simply the energy we never have to use. This has to be paired with fully decarbonizing our transportation sector. Think electric vehicles and much better public transit. We also need to restore our natural carbon sinks like ancient forests and wetlands and invest heavily in sustainable agriculture. And for those really stubborn, hard to decarbonize industries, we've got to double down on investing in carbon capture technologies. When we compare the potential future scenarios side by side, it shows us exactly why immediate action matters so much. Climate scientists map out these different outcomes based directly on what we choose to do today. In a high-emission scenario where we basically just keep increasing emissions like business as usual, we face incredibly severe climate impacts and a dangerously high risk of crossing those irreversible tipping points. Even an intermediate scenario leaves us dealing with high warming and absolutely immense adaptation challenges. But in a low-emission scenario, where we drive a rapid, focused decline all the way to net zero, we lock in a dramatically safer world. We're talking lower sea level rise and way fewer extreme weather events. The math is simple. Earlier, deeper emissions cuts lead to drastically better outcomes for all human societies.
The source material summarizes this entire incredibly complex issue absolutely beautifully. Every action that limits additional warming contributes to a more resilient, sustainable, and prosperous future. It's such a powerful reminder of our shared, collective human responsibility. The science of accelerating global warming isn't just some dry academic exercise to read about. It is the ultimate call to action for all of us.
Which leaves us with one final vital thought to ponder. We know the warming is accelerating, we know the stakes are incredibly high, and we know exactly what we need to do to slow it down. So the only question left is, what role will you play in the critical fractions of a degree we have left to save? Thank you so much for joining me for this explainer today. Keep learning, stay curious, and take action.